Hi boys and girls, this is your instructional video for lesson 1-2 proportional relationships, right? Okay, proportional relationships begins on page 13 of your workbook. Page 13 of your workbook. Your I can statement, I can use models and ratio reasoning to understand how a proportional relationship can exist between quantities. The vocabulary for this lesson is just one word, well, one phrase, proportional relationship. All right, and there is a video already where I tell you how to fill out the proportional relationship vocabulary sheet. All right, well, this is a whole lot of print on one page, but I'll try to summarize what it says. This is also on page 13. When baking, the ratio of ingredients is important to maintain. The table shows a common recipe for pizza dough. Too much or too little of any one ingredient will not make a good dough. In the recipe, the ratio of cups of flour to cups of water is 3-to-1. That means for every 3 cups of flour, you have to add 1 cup of water. If you wanted to make a double batch, you could have 6 cups of flour and 2 cups of water. You have to increase both, and you increase them by the same amount. So if you were going to double the flour, you have to double the water. That's basically what this says. If you're going to triple the flour, you have to triple the water. This is on page 14, also a whole lot of words. It basically says that 2 quantities are in a proportional relationship if the 2 quantities vary and have a constant ratio between them. And I'm going to explain that as best I can. It's kind of an obscure concept. Basically, they're going back over and saying, okay, so this is a proportional relationship if a recipe calls for 2 cups of flour for every 1 cup of sugar. So if you double the flour, you go with 4 flour, then you have to go with 2 sugar. Okay, you double the sugar. Some relationships are not proportional. For example, if Pedro is 14 and his brother is 7, well, Pedro's twice as old as his brother. But the following year, Pedro's going to be 15 and his brother's going to be 8, and that's not double anymore. So they're saying that's not a proportional relationship. And here they try to show you that, they're saying, oh, in 5 years, it's not going to be double. It's only double right here at this point. So this is not a proportional relationship. Okay. This was the vocabulary page that we did on the vocabulary video. This is the one we filled out. Let's see. Identifying proportional relationships. I don't know where to put this thingy this time. All right. So the recipe for a homemade glass cleaner indicates to use a ratio of 1 part vinegar to 4 parts water. Okay. Well, Elise used 3 tablespoons of vinegar and 12 tablespoons of water to make the cleaner. Okay. Is the relationship between the vinegar and water in the recipe and the vinegar and water in Elise's cleaning solution a proportional relationship? Well, it goes on to say that for every 1 part vinegar, there are 4 parts water. So basically what you got to have is the water always has to be 4 times the vinegar. If she uses 3 tablespoons, is 12 tablespoons 4 times the vinegar? Yes, it is. Okay, so there's a whole lot of words and drawings to just tell you that. The relationship is the water has to be 4 times as much as the vinegar. It doesn't matter how much, but it's got to be 4 times as much. So if 3 tablespoons and 12 tablespoons, it's 4 times as much. This is a proportional relationship. All right, so then it says, refer to the recipe for homemade glass cleaner in example 1. Marcus mixed 1.5 cups of vinegar and 6 cups of water to make his cleaner. Is the relationship between the vinegar and water in the recipe and the vinegar and water in Marcus's cleaning solution proportional? Remember, I said that for every 1 vinegar, get my little writing utensil, for every 1 vinegar, you have to have 4 waters. Doesn't matter if it's cups, tablespoons, gallons, it's 1 to 4. Okay, so he's got 1.5 cups of vinegar and 6 cups of water. Okay. Is 6 4 times 1.5? Well, yes, it is. Okay. Another thing you can do when you have 2 simple ratios like this and you want to know if they're equal, you can cross multiply them. Multiply 1 times 6 and I get 6. and I multiply 4 times 1.5, and I also get 6. If these two numbers are the same, then you have a proportional relationship. If these two numbers had been different, if one was 6 and one was 7, it's not proportional. That's one way to tell if two ratios are proportional. There are other ways, though. Okay. A 5-mile taxi ride in one city costs Ayana $25. A 4-mile taxi ride in a different city costs $18. Is it proportional? Okay, let's use our same system. All right, we know that a 5-mile ride costs her $25. What is she paying per mile? Well, you just divide 25 by 5 and you would get 5. So Ayana is paying $5 per mile, per 1 mile. So if it's proportional, then the money should be 5 times the miles. All right. Well, in a different city, we had 4 miles and we have $18. Well, we know that the money has to be 5 times the miles. What's 5 times 4? It's 20, not 18. Now, you could have set this up as a ratio and cross-multiplied it. You need to write yourself a word fraction because you have to decide what number am I going to put on top, okay? Since they give it in dollars per mile, let's put dollars on top and miles on the bottom. Now, if I had to put Ayana's, I could have even used the original one they gave me. I didn't even have to simplify it. I could have put that it's $25 for 5 miles, and in another city, it's $18 for 4 miles. And now, let me get rid of some of this. Now what I want to do is cross multiply, okay? What is 25 times 4? Well, that's 100. What's 18 times 5? It's not 100, I'll tell you that. 18 times 5 is 90. So this is an example where we cross multiplied. We multiplied the numbers that are across from each other to see if they were equal. Because 90 does not equal 100, this is not proportional. Okay. All right, moving on. Here we have one type of yarn costs $4 for 100 yards. Another type of yarn costs $5 for 150 yards. Is the relationship between the number of yards and the cost a proportional relationship? Well, let's see. We've got yarn and we got yards and dollars. So let's do dollars again on top. It's dollars per yards. So let's do dollars per yards. And we do the word fraction because we want to be consistent. If we're going to put money on top, we have to continually put money on top. In the first scenario, we have $4 for 100 yards. Is that equal to $5 for 150 yards? Now, some of you with good math sense are going, no, that's not equal. That's not going to work. But you could check this, all right? You could do 5 times 100 is 500. And 4 times 150 is 600. That is not equal. This is not proportional. Another way you can solve these is you can reduce these to lowest terms, okay? This reduces, these both divide by 5, okay? And so this would be 1 over 10? No, 20, 10 more, 30. And this one reduces to 1 over 25. If these had reduced to the same fraction, this would be proportional. Because they don't reduce to the same fraction, it's not proportional. So you have some options when we're talking about proportional. You can reduce the ratios to lowest terms and see if they're equal. You can cross multiply them and see if that gives you an equal number. That's not the only ways to do this. Here we have, they're complicating this. Now they're giving you 3 things. This is a really tricky problem. I had to look at this one for a minute. This one, Christine is building a deck in her backyard. In order to place the posts, she will make concrete using a mixture. The mix requires 1 part water to 2 parts cement to 3 parts sand. We've got 3 things that we have parts for. All right, we're not going to be able to use those little fraction thingies because we've never seen a fraction with 3 parts. We're going to have to do this differently. So here's what we got. We've got water, cement, and sand. So here's what I recommend you do. Water, cement, and sand. Okay, so we get 1 part water, 2 parts cement, and 3 parts sand. I'm making a table here in case you can't tell. These are not the straightest lines, but it's not easy to draw with the graphic tablet. Okay, so that's how it works. The cement's got to be double the water, and the sand has to be triple the water. Okay, so we go on reading. It says the relationship between them is proportional. If she has 25 pounds of cement and wants to use it all, how many pounds of sand will she need? Well, if she's got 25 pounds of cement, what do we multiply 2 with to get 25? Well, that's kind of an oddball. You could put 25 divided by 2 in your calculator, but I'm telling you, you're multiplying times 12.5, okay? So what's 12.5 times 1? Well, 12.5. And then what's 12.5 times 3? All right, 12.5 times 3 would be 37.5. Right? So what we're doing here is we're saying that whatever this number is, we're multiplying it times 12.5. All right, multiplying this times 12.5. And we got that 12.5 because we were forced to use a 25-pound bag of concrete. And it just so happened that that was the 2-parter. So we divided 25 by 2. We found out what the answer to that was, and then we multiplied 1 times it, and we multiplied 3 times it. So the first question is, how many pounds of sand will she need? She will need 37.5 pounds of sand. Oh, I wrote sand twice. Well, that was dumb. Yeah, I undumbed it. Okay, so the next question, it says 1 gallon of water weighs about 8.34 pounds. How many gallons of water will she need? Round to the nearest tenth. Okay, so apparently it's a pound of water. This is a pound of, we're doing this all in pounds here because cement and sand are sold in pounds, so they want to do it in pounds. Don't worry, I won't put one like this on the quiz. We're just doing this one for fun at this point. Okay, so if a gallon of water weighs 8.35 pounds, all right, we need 12.5 pounds of water. Okay, that's what this says. So how many gallons of water do we need? Well, what we need to do is we need to find out how many 8.34s are in 12.5, which means a division problem. We're going to take 12.5 and we're going to divide it by 8.34. Again, I would not ask you to do this problem without a calculator, all right? We don't have time for that. Turn on my calculator. I want to know 12.5 divided by 8.34. That is, we're going to round to the nearest tenth, is 1.5. So water, we need 1.5 gallons. And this was pounds. So I told you that was kind of a tricky, convoluted little problem there. It was not the easiest problem on the planet, but like I said, I'm not going to assign something like that to you. Right. Moving on, we have the check on page 18. Okay. A basic slime recipe. Well, at least they're finally using stuff that is intriguing to kids, A basic slime recipe calls for 1 part borax, 24 parts white glue, and 48 parts water. Oh boy, I feel a table coming on. All right, we have borax, which you probably don't even know what that is. It's some kind of soap. 1 part borax, white glue, we need 24, so we have to have 24 times white glue. We have to have 24 times as much white glue as we have borax. And then water, we have to have 48 times as much water as we have borax. The relationship between borax, white glue, and water is proportional. They have to say that. If Catalina has 3 tablespoons of borax and will use it all, 3 tablespoons of borax, and we'll use it all. How many cups of white glue does she need? All right. 1 cup equals 16 tablespoons. Oh, she has 3 tablespoons. Okay, so we have 3 tablespoons. So that means that white glue has to be 24 times as much. All right. What's 24 times 3? 72? 72? And I can't do the next one in my head. No. Okay, we got to multiply 48 times 3. If I tried, I'd probably screw it up. All right, that's 144. So how many cups? They want to know how many cups. Guess what? We're working in right here. These are tablespoons. Was it tablespoons or teaspoons? Tablespoons. We're working in tablespoons. So they want cups, okay? And they want to know how many cups of glue. So I need to know I have 72 tablespoons of glue. How many cups is that? Well, they gave us a hint. 1 cup is 16 tablespoons. So we need to divide 72 by 16. And that is 4.5 cups of glue. That's a lot of glue. We're not going to be making this. No. And we're not going to have a problem like this on the assignment. All right, so that brings me to the end of the notes section. I will film a separate section to do these practice problems. This is just for your notes and just for the instructional part of the video. Like I said, I will film a new video to go along with the practice problems. That will be over on McGraw-Hill for you next week. All right, well, I guess by the time you see this, it will be next week. Unless you're one of those kids that's sitting around watching my YouTube channel going, oh, she put up a new video, I got to watch it. You could be. Never mind. Okay, I'm just rambling. All right, thanks for watching. Have a great day, and I will see you in class.